Okay, good morning, and thank you very much for joining this early. So we are going to continue with the discussion on multiple discrete random variables. Next time we are going to start with the continuous random variables. Today we will finish the discussion on multiple discrete random variables. So the concept of multiple discrete random variables is that if you have a sample space with some sample points, a mapping of these sample points, all of these sample points onto the real line, this defines a random variable. कि अगर ये आउटकम आ गई तो x is 5, ये आउटकम आ गई तो x is 7, ये आउटकम आ गई तो x is 25. So this is a mapping of all of these sample points onto the real line. Similarly, if you map these sample points onto the real line in a different mapping function by using a different mapping function. So same real line के ऊपर उनको map करना है. लेकिन ये outcome आ गई तो another random variable y will take the value 75, this value y takes the value 95, this y takes the value 243. So you can define all of these outcomes to be mapped onto either x or y or z or any random variable. So take each of those outcomes and map those onto real line, you will get one new random variable. Infinite possibilities to define the random variables here. Okay. So we have x and y, two different random variables defined on the same sample space. And the example was very simple. Toss a coin, the sample space consists of only two outcomes, head and tail. You can define two random variables, x taking the value 32 and 46 if head appears, and tail if tail appears, then 46. Similarly, on the same sample space, I can define y to be taking value 91 if head appears and 103 if tail appears. So you can see that from the same experiment, I have gotten two different mappings. So two different random variables. Now, once you have two random variables or 3 or 4 or 5, you can answer all the probability questions involving these random variables alone or jointly. So for example, I can ask the question, what is the probability x takes the value 32? I can ask the question, what is the probability that y is greater than x? What is the probability y is greater than x? So I can ask all sorts of questions involving the random variables. Okay. And last time we did an example of the joint probability distribution, discrete probability distribution. Okay. We will continue with that. So joint probability mass function, joint PMF. Okay. The notation that we use is Px, y, two random variables x and y. Their joint PMF or joint probability mass function is given by, first we recall okay, for a single case, for a single random variable, Pxx was equal to probability random variable x takes the value small x. By the same token, this is equal to probability x takes the value x and y takes the value y, So you can notice that x taking the value x is an event, probability of this event. Similarly, this is an event that x takes the value x and y takes the value y. This is a joint event. Intersection of two events, x taking the value x and y taking the value y. What is the probability of intersection of those two events? Okay. So similarly, we can define the joint CDF, cumulative distribution function. And once again, if you recall, for a single random variable, the joint CDF was probability x takes the value less than equal to small x. Accumulated values. यहाँ पे ये x is equal to x है, यहाँ पे x less than equal to small x. Similarly, we can define the joint CDF of two random variables, capital F x comma y, x comma y is equal to the probability that x takes the value less than equal to small x and y takes the value less than equal to small y. This is one event, this is another event. And the probability of intersection of these two events, is the joint CDF. Now, last time we saw that from the joint PMF, can find the marginal PMF. यानी अगर हमें x और y का joint PMF दिया हो तो उसमें से x को sum out कर देते हैं तो you will get the PMF of y, और y को अगर sum out कर दें तो you will get the PMF of x. Okay. Similarly, in the case of CDF, I can obtain the marginal CDF of x. When I say marginal CDF of x means a single random variable का CDF. Okay. I can obtain the marginal CDF of x by saying that fx evaluated at a, we know that this is equal to probability x less than equal to a. Can I find this marginal CDF? Can I find this marginal CDF from this guy? And the answer is yes. Otherwise, we wouldn't have been asking these questions. And this would be probability. Convince yourself that this probability of an event x taking a value less than equal to a, अगर मैं इसका intersection कर दूं एक ऐसे event के साथ जिसकी probability हमेशा 1 ही होगी, which is y taking a value less than equal to infinity. You know y always takes a value less than equal to infinity. I will always take a value less than equal to infinity. Okay. So this guy is called this is our joint CDF, and this is capital F of x comma y evaluated at a comma infinity. So this is giving you the marginal CDF of x from the joint CDF of x and y. So last time we had seen that joint PMF से आप marginal PMF मालूम कर सकते हैं by summing out y और summing out x. y को sum out करेंगे तो x का आ जाएगा, x को sum out करेंगे तो y का PMF. Okay. Similarly, you can find the joint CDF से marginal CDF. Now, let's take a look at PMF and conditioning. Last time we touched upon this topic briefly because we will have another example. So first of all, I'm going to talk about conditioning on event. Conditioning on an event. So I can find the conditional PMF of x given some event A. Can be found as follows. Okay. The notation that we use is PMF of x given A. So यहाँ पे आप ये देखें कि this is nothing but the PMF of x, and this is conditioned on A. Everything is given on A. So this is equal to the probability that x takes the value x given the event A happens. Okay. Natural definition. वैसे PMF की definition क्या होती है? वैसे PMF की definition है Px of x is equal to the probability x takes the value x. Okay. If I condition this on event A, then I'm talking about the probability x takes the value x given the event A. Okay. Now you might notice that this x is equal to x. This is also an event. So what is the probability of one event given the other event? ये हमने conditional probability में पढ़ा था. And this is equal to the intersection x is equal to x and the event A divided by the probability of event A. Probability of oops. Normally we use these kind of brackets. So I will give you an example to show you that PMF you have given the event A, the PMF can get distorted. So I will give you an example using the one diagram. So let's say this is your sample space and you have this event A. ये आपके पास event A है. This is your sample space. Okay. Let's say you have this random variable capital X which can take two possible values, x1 and x2, x1 and x2. And let me just try to draw those. So this is an event that x takes the value x1. This is an event that x takes the value x1. Let me also define another event that x takes the value x2. So I have intentionally drawn this green space to be smaller than the blue space, So it is interesting to note that if I draw the PMF of x, so small x taking the value x1 and taking the value x2, there are only two possible values the random variable x can take. It can take the value x1 with a larger probability. ये blue वाले का area देखें. This guy has a larger area as compared to this guy. ये draw ऐसा मैंने किया. ठीक है. So x1 has this and x2 probably something like this. But given A, we notice that okay, this intersection area here and this intersection here, area here. So now you can see, okay, relatively speaking, x will likely take the value x2 if event A is given. So if I draw this guy here, PMF of x given A, So this is P x given A, small x given A. So on this side we have x. Once again, x can take the value x1 and x2, but now it will take the value x1 with a smaller probability and x2 with a larger probability. So ये दोनों जो हैं PMF of x हैं, one is unconditional, the other is conditional. So you can see that given the event A, the PMF of x can be distorted, change हो सकता है. Obviously, if random variable x is independent of event A, then these two PMFs will be exactly the same. Okay. So this is conditioning on an event. Just like you can condition on an event, this event A could be another random variable taking some value. So for example, event A can be y taking a value small y. ये ऐसा हो सकता है, ठीक है? Which leads us to the second way of conditioning. One was the conditioning on an event. The second way of conditioning is conditioning on a random variable. When we say that conditioning on a random variable, this really means that conditioning on a random variable taking a particular value. Okay. So the conditional PMF of x given y is equal to y. So this is conditional PMF of x given y is equal to y. This is equal to the probability that x takes the value x given y takes the value small y. Y takes the value small y. Once again, if you notice, this guy, x taking the value x is an event, y taking the value y is also an event. Probability of one event given the other event. Conditional probability formula, which is probability x takes the value x and y takes the value y divided by probability y takes the value y. Standard conditional probability formula. But what we have up here is the joint PMF of x and y, joint PMF of x and y. And what we have down here is the marginal PMF, or just the PMF of y, just the PMF of y. So joint divided by marginal would be equal to this conditional event. Okay. We can similarly define the conditional CDF of x given y. Conditional CDF of x given y is equal to y is given by capital F, x given y is equal to the probability x takes a value less than equal to x given y is equal to 1. And of course, this can also be written down by using the conditional probability formula, which is probability x takes a value less than equal to x, y takes a value y, divided by probability y takes the value y. So we'll do an example. एक example करते हैं. Simple example. So let's say you are given the joint PMF. Joint PMF आपको दिया हुआ है, ठीक है? And in the joint PMF, you have two random variables, x and y, and x takes the value 0 and 1, y also takes the value 0 and 1. Y takes the value 0 and 1. So this is y here, and this is x here. X can take the value 0 and 1. So the joint PMF is 0.4 here, okay, and 0.1 here, 0.2 here, and 0.3 here. This is the joint PMF which is given to you. Joint PMF which is given to you. So I'm going to ask some questions and you can probably answer. You can answer in the chat window. What is the probability x takes the value 0, y takes the value 1, which is x comma y 0 comma 1? What is this answer in the chat window? दिया हुआ है यहाँ पे. X takes the value 0 and y takes the value 1, which is this guy 0.2 here. So I write 1. ठीक है? So what is the probability? What is the probability x takes the value 0? What is the probability x takes the value 0? Answers in the chat window. This is the marginal PMF of x given marginal PMF, which is obtained by summing upon all y PMF of x and y x y. Oops. और ये x is equal to 0 पे हम evaluate कर रहे हैं, तो यहाँ पे x is equal to 0. So joint PMF, sum it over all values of y, you will get the marginal PMF of the other guy. Y पे sum किया है, तो आपको marginal PMF of x मिलेगा. ये हम x is equal to 0 के लिए कर रहे हैं. Of course, we can find it for x is equal to 1, which is summed over all y, p, x, y, x taking the value 1 for every value of y. So what would be this value? Answers in the chat window. What is the probability x takes the value 0? X takes the value 0 with probability 0.6. ये सबने बताया. X takes the value 1 with probability. ये देखें, y की सारी values पे sum कर दें. X takes the value 1, y की सब values पे sum कर दें, और सब values पे sum करने से this will be 0.4. सब values पे sum करने का मतलब है Okay, we are writing pxy 1, 0 plus pxy 1, 1. So this is 1, 0 and this is 1, 1. दोनों को add कर देंगे तो we will get 0.4. So what that means is that this guy here is the probability x takes the value 1 or px1. Similarly, this guy here, इन दोनों को जब sum करेंगे, so you will get px0. वही हमने यहाँ पे 0.6 लिखा. Now, the real question here is, okay, what is the conditional Pmf? Conditional Pmf. Conditional Pmf of x given y is equal to 1. सबसे पहले आपको intuitively बताते हैं. When y is equal to 1, that means we are limiting ourselves to this guy. ये ब्राउन में जो मैंने सर्कल कर दिया है, we are limiting ourselves to y is equal to 1. ये इसी पे y is equal to 1 है. This guy. But you can see that this is not the PMF. This is not the PMF. Why is it is not the PMF? ये x taking the value 0 with probability 0.2 and taking the value 1 with probability 0.3. This is not the PMF. Why is this not a PMF? ये जो brown के अंदर है, this is not the PMF. क्यों PMF नहीं है? Answers in the chat window. Why is this not a probability mass function? Well, the sum does not equal to 1. ये 0.2 और 0.3 ये add होके 1 नहीं बनते. Conditional. So probability mass function के लिए जरूरी है कि उसकी सारी वैल्यूज को प्रोबेबिलिटी वैल्यूज को आप ऐड करें तो 1 होना चाहिए. ओके, सो दिस डज नॉट ऐड टू 1. व्हाई इज दैट? बिकॉज हमने अब लिमिट किया है, हमने कंडीशन किया है y इज इक्वल टू 1 के ऊपर. सो y इज इक्वल टू 1 एक ऐसा इवेंट है कि नाउ आई हैव अ रिड्यूस्ड सैंपल स्पेस. नाउ y कैनॉट टेक अ वैल्यू 0. नाउ y हैज टू टेक अ वैल्यू 1. इफ वी नो दैट y टेक्स अ वैल्यू 1, जब रिड्यूस्ड सैंपल स्पेस होती है तो फिर हमें उसको y की प्रोबेबिलिटी से जो ये है उससे डिवाइड करना पड़ेगा. सो दैट मींस वी विल नीड टू नॉर्मलाइज दिस गाय. 0.2 और 0.3 वाले को नॉर्मलाइज करना पड़ेगा. सो लेट्स डू दैट एंड वी डिड इट अप हियर एक्चुअली. सो PMF of x given y is equal to y is simply the joint divided by the marginal of y. Joint divided by the marginal of y. Okay. So PMF of x given y, हमने ऊपर लिखा है. This is simply the joint of x and y divided by marginal of y. Okay. So that means that we are required to find the conditional PMF of x given y is equal to 1. So we are interested in finding Pxy x given 1. X given 1. Y takes the value 1. Okay. So this is equal to Pxy x comma 1 divided by Py of 1. Py of 1. But what is Py of 1? Py of 1. Answers in the chat window. Py of 1. Answers in the chat window. What is the probability y takes a value 1? Well, sum up on all the x, Pxy, x, y, taking the value 1. So y taking the value 1, इसको sum up करें तो ये आपके पास आ जाएगा 0.2 plus 0.3. The brown guy here, which is 0.5, of course. So the probability that y takes a value 1 is 0.5. So now Px given y, x given 1 is equal to Pxy, x given 1 divided by 0.5. Divided by 0.5. This is our conditional PMF of x. लेकिन हमें हर वैल्यू के लिए बताना पड़ेगा. X takes the value 0, X takes the value 1. So Px given y 0, 1, ये क्या हो जाएगा? This would be Pxy 0, 1 divided by 0.5. And this is equal to 0.2 over 0.5, which is 2 over 5. Similarly, Pxy given y 1, 1, sorry, this should be given 1. Conditional के अंदर आपको given 1 given 1 is equal to Pxy 1, 1 divided by Py1, which is equal to 0.3 divided by 0.5. So it's 3 over 5. And now you notice that these two guys here, they sum up to 1. इनकी summation अगर करें तो you get a 1. So this is a conditional PMF. By the way, conditional PMF is also a PMF. Conditional PMF is also a PMF, is also a probability mass function. So I am saying that some event happens that y takes the value 1. That's an event which happens. This is given to you. Given this event, I'm asking you what is the probability mass function of X. And the probability mass function, even if it is conditional on something, the probability mass function must add up to 1. Okay. So when we talk about the conditional probability, we talked about independence. So just like we talked about the independence of events, we can talk about the independence of random variables. Independence of random variables, X and Y. If there are two random variables, X and Y, these two random variables are independent if any event involving X and any event involving Y are independent. X, Y independent if and only if any event involving X, अभी आपको ये बताते भी हैं कि what does that mean, event involving X? If any event involving X and any event involving Y are independent. And we already know the independence of events. So recall करते हैं कि probability of A and B, if A and B were independent, then this was simply equal to probability of A into probability of B. This was the independence of A and B. ये दो events थे A और B, ये उनकी independence थी. We did it, a few lectures ago. So now what do we mean by an event involving X? An event involving X. So मैं ऐसे event बना देता हूँ. So probability X belonging to some set A and Y belonging to some set B. This is an event, X belonging to A and Y belonging to B. These are two events. These two events will be independent when I can write this into X, Y belonging to B. ऐसे ही होता था, right? So this is an event X belonging to A, X is an element of A. This is an event involving X. This is an event involving Y. When these two events are independent, for all possible, for any event involving X and any event involving Y, then we say that random variables X and Y are independent. What this implies is with the special events that are defined करके देखते हैं. So one special event is probability X less than equal to A, Y less than equal to B. This is an event involving X. This is an event involving Y. X less than equal to A is an event involving X. Y less than equal to B is an event involving Y. If these two events are independent, what that means is keep X less than equal to A into X less than equal to Y less than equal to So this is a specific case कि मैंने ये कह दिया कि x less than equal to small a, y less than equal to small b. So this, if you know, this is the joint CDF of x and y evaluated at a and b. This is the marginal CDF of x, and this is the marginal CDF of y. What this tells us is that the product of the marginals is equal to the joint CDF, एक और चीज PMF के लिए भी देखते हैं, probability x taking a value a and y taking a value b not less than equal to. Again, these are two events. One is event involving x, another is event involving y. If x and y are independent, then this should be equal to x taking a value a and probability y taking a value b. So this is equal to pxa, pyb, and on the left we have pxy a comma b. So this is marginal PMFs, and this is the joint PMF. This is the joint PMF. Okay. So you can see that the joint PMF is the product of the marginal PMFs. Not always true. अगर independent नहीं होंगे x और y, तो फिर ऐसा नहीं होगा. And we can prove that, and we can prove the converse. Okay, if x and y, their marginals, product of the marginals can be written as the joint, then x and y are independent. So vice versa भी true show कर सकते हैं. So proof जो है वो it's given in the notes. Please take a look at that. वो हमने दिया हुआ है वहाँ पे. So I'll give you an example. I will give you an example. So let's say you have independent trials. Okay? Independent trials, n plus m independent trials. ये जिस तरह हम बाइनोमियल के केस में करते थे, बाइनोमियल रैंडम वेरिएबल के केस में, कि you have n trials. यहाँ पे मैं कह रहा हूँ कि n की बजाय n plus m trials हैं. Each of those trials are independent. So maybe each trial includes rolling one dice or two dice or a dice and a coin. Okay. हर trial में आपने एक experiment form करना है, and then the overall experiment consists of a sequence of those trials, and you have n plus m such trials. Okay, and p is the probability of success in each trial. Let's assume that you have these trials. उसमें पहले आपके पास n trials हैं और उसके बाद आपके पास m trials. N trials and then m trials. So total n plus m trials. Let me define x to be equal to number of successes in first n trials. So x is clearly a binomial random variable. X is a binomial random variable with parameters. इसके parameters बताएं. Answers in the chat window. What are the parameters for x being a binomial? What are the parameters of that binomial distribution? कितने trial किए हैं और probability of success in each trial. So this is a binomial n comma p. What is the expected value of x? The expected value of x is n times p. What is the variance of x? N times p into 1 minus p. ये हमने binomial की expected value और variance जो है last lecture में हमने मालूम किया. So x is a binomial with n comma p. Y is the number, I define y to be as the number of successes in last m trials. So y is also binomial also binomial with parameters m comma p. M comma p. M is the number of trials, p is the probability of success in each. N is the number of trials, p is the probability of success in each. So x is binomial, y is binomial. X is binomial, y is binomial. Okay. Who thinks x and y are independent? Who thinks that x and y are independent? ये इंट्यूटिवली वैसे नजर आ रहा है, ये पहले n ट्रायल्स जो हैं इनमें जो कुछ हो रहा है बाद वाले m ट्रायल्स में कोई ताल्लुक नहीं है उनका. So it is clear that x and y, they do not impact each other. They do not impact each other. What is the joint PMF of x and y? Which means the probability x takes the value small x, capital Y takes the value small y. So this is equal to x taking the value small x is binomial random variable taking a value x. So n choose x, p power x, 1 minus p, n minus x. This is the probability that x takes the पहले n trials में आपके पास x successes आ जाते हैं. पहले n trials में आपके पास x successes आ जाते हैं. And then आखिरी वाले m trials में आपके पास small y successes आ जाएंगे. M choose y, p power y, 1 minus p, m minus y, and you can readily see that the marginal of x and this is marginal of y. The product of these two is the joint PMF here. In the same example, I will show you an example. I will show you a situation when the random variables are not independent. Okay. Define z as the total number of successes in n plus m trials. What is the distribution of z? Is z a binomial? Yes or no? Is z a binomial? Yes or no? Answers in the chat window. Is z a binomial random variable? Of course z is a binomial random variable. अभी हमने z की definition में कहीं x y इस्तेमाल ही नहीं किया. हमने ये कहा कि n plus m trials हैं और probability of success in each trial is p and each of the trials are independent. Then z is the number of successes in those m plus m trials. So z is a binomial with parameters. Answers in the chat window. With parameters n plus m p. Okay. So probability z takes a value small z is equal to n plus m small z p power z 1 minus p n plus m minus z. ये binomial की definition. You can notice that x and z, are they independent? Well, they are not. अगर हम आपको बता दें कि z takes a value 0, तो automatically हमें पता है कि x will take the value 0. So given z, x की जो PMF है वो चेंज हो जाएगा. x का PMF चेंज हो जाएगा. अगर हम आपको बता दें कि z is n plus m, z takes the value n plus m, which means कि सारे trials जो हैं वो successes हैं, then x will take the value n. So that means कि x and z, they are not independent. I'll give you another example. So let's say there is a post office here. There's a post office and people are entering the post office. ये आपके पास गेट है, लोग यहाँ से जा रहे हैं. And these people can either be males or females. So the people entering the post office, people entering post office. People entering post office. Let's say that this number is defined as a Poisson with parameter lambda. Lambda is the rate of Poisson. So remember, Poisson was an approximation to binomial. Binomial में आपके पास number of successes होती हैं. यहाँ Poisson में भी ये आपके पास expected number of successes हैं. So lambda is that expected number of successes. Poisson with the parameter lambda. Okay. So now let's also assume that each person is male with probability P, and female with probability 1 minus P. Okay. The question is, and this might be counterintuitive, I'm warning you ahead of time. So X is the number of males entering in the post office on a given day, and Y is the number of females entering the post office on the given day. The question is, are X and Y independent? Are X and Y independent? क्या लगता है? They are independent or no? Well, this might be a bit counterintuitive for this kind of distribution. This might be counterintuitive. So इसको solve करते हैं. So PXY, X taking a value I, Y taking a value J is the joint PMF. So this is equal to the probability X taking a value I, Y taking a value J. ये हम कैसे मालूम करेंगे? Now let's condition it on X plus Y is equal to I plus J. X plus Y is equal to I plus J. इसको condition करते हैं. So this is equal to probability X is equal to I, Y is equal to J, given X plus Y is equal to I plus J into the probability X plus Y is equal to I plus J plus probability of X is equal to I, Y is equal to J. ये law of total probability से लिख रहे हैं. X plus Y not equal to I plus J into the probability X plus Y not equal to I plus J. So easy to see that when X plus Y is not equal to I plus J, if it is given to you, the probability that X is equal to I and Y is equal to J, this guy is 0. ये कभी हो नहीं सकता कि X is equal to I हो और Y is equal to J हो और X plus Y is not equal to I plus J. Not possible. So what we have here is equal to probability X is equal to I, Y is equal to J, given X plus Y is equal to I plus J. X plus I is equal to I plus J. Now, what we are saying here is that I plus J people are entering the post office. It is given to you. The total number of people, males or females together, entering the post office is I plus J. So what this equation is telling us is above expression, given I plus J is the total number of people entering the post office. I plus j is the total number of people entering the post office. ये लोग जो हैं वो enter हो गए हैं, I plus j people. Now, what is the probability? What of the probability that I are male? I of them are male. Probability I of them are male. So think about this. Think about this. कि ये जो I plus j लोग अंदर enter हो गए हैं, for every person, think of it as a trial. Think of it as a trial for every person. Think of it as a trial for every person. And trial क्या है कि या वो male होगा, which is success, या female होगा, which is failure, or vice versa. जैसे भी उसको बोलते हैं. So I am asking you this question कि I plus j trials आपने किए, I plus j trials, उसमें से probability of I successes का मतलब males हमने define कर दिया, for example. So what is this probability? So this looks like a binomial to us. कि I plus j trials करते हैं, each of those trials are independent, क्योंकि हर trial के अंदर one person can either be a male or a female, and I am interested in the probability of I successes because I am interested in probability x taking the value I. Okay. So what is the probability of I successes when you perform I plus j trials? This is a binomial distribution. So this should be equal to I plus j choose I. This is the total number of trials. Ye total number of trials hai, and this is the number of successes. Total trials, and this is number of successes. Here hame chahiye. Yeah. Into the probability of success in each trial, p power I, and 1 minus p power I plus j minus I. So this is the probability. कि आपने given you have performed I plus j trials, what is the probability that you will have I successes? When you have I successes, you will automatically have j failures by taking a value j failures. Okay, j उसमें से females आ जाएंगे. So very interesting कि ये तो आपके पास binomial distribution निकला है. Binomial distribution. So now, this equation here, यहाँ पे हमारे पास एक ये probability x plus y is equal to I plus j. So we have found कि this probability here, ये जो मैंने box में डाल दी है, this is binomial. This is binomial with parameters I plus j with the probability of success p. Okay. Now, what is this guy? ये जो बाद वाला है, what is this guy? Probability x plus y is equal to I plus j. X plus y is equal to I plus j. What is this probability? What is the probability x plus y is equal to I plus j? Answers in the chat window. So notice that x is the number of males and y is the number of females. So x plus y is the total number entering. Or total number entering, ये तो हमने आपको बता दिया था. People entering the post office is a Poisson with lambda. Parameter. Okay. So total number of people entering the post office is Poisson lambda. So x plus y is a Poisson random variable with parameter lambda. ये तो given है. This is given that the number of males and females together entering the post office, the number of people entering the post office is a Poisson with parameter lambda. So this is simply asking the question that a Poisson random variable with parameter lambda, what is the probability it's taking a value I plus j? What is that probability? So that should be equal to lambda power I plus j e to the power minus lambda divided by I plus j factorial. ये Poisson है. This is your Poisson random variable. ये Poisson की distribution. And the Poisson random variable taking the value I plus j. Therefore, now I have found this guy here, which is this green guy here, and we have also found this red guy here, which is the binomial distribution. So I can now write the joint PMF of X and Y. Okay. So P X Y I comma J is equal to the product of this guy and this guy, which is equal to I plus J choose I P power I 1 minus P. So ये I plus J minus I है, इसको हम सिर्फ J लिख देते हैं, and then multiplied by this Poisson guy, which is lambda power I plus J e to the minus lambda over I plus J factorial. Okay. So थोड़ा सा इसको ओपन करते हैं. So I plus J choose I is I plus J factorial divided by I factorial J factorial. ठीक है. और this P power I, in fact, let me just change the color. This P power I can be combined with this lambda power I to give you lambda P power I. ठीक है. और ये 1 minus P power J और ये lambda power J इसको combine करते हैं. So this would be equal to lambda into 1 minus P power J. Lambda into 1 minus P power J. And then we have e to the minus lambda. E to the minus lambda divided by I plus J factorial. And this I plus J factorial goes away. This I plus J factorial goes away with this I plus J factorial. So what we have here is lambda P power I over I factorial. मैं इसको थोड़ा सा मूव कर देता हूँ. For some reason, into lambda into 1 minus P power J over J factorial. और ये e to the minus lambda जो है मेरे पास, इसको भी मैं ब्रेक कर देता हूँ. I can write this as e to the minus lambda can be written as e to the minus lambda P multiplied by e to the minus lambda 1 minus P. किसी को इस पे एतराज नहीं. So I can write it as e to the minus lambda P e to the minus lambda 1 minus P. Now, what is this guy? Answers in the chat window. Recognize this. इसको recognize करें, ये क्या चीज है? अरे ये अभी ऊपर लिखा था Poisson distribution. This is a Poisson distribution. This is a Poisson distribution evaluated at I. This is simply equal to the probability X taking a value I and Y taking a value J. So you can see that there is a clean separation of I and J terms here. So आप देख सकते हैं इसमें कि PMF of X and Y वो I और J वाली terms जो है वो product में अलग हो गई हैं. So that means the product of marginals. This is joint, which turns out to be the product of marginals. It's a product of marginals. Since it's a product of marginals, that means X and Y are independent. लगता काउंटर इंट्यूटिव है कि अगर हमने बता दिया कि सारे फीमेल्स हैं तो मेल की प्रोबेबिलिटी खत्म हो जाएगी. बट दिस डिस्ट्रीब्यूशन इज सच दैट कि यहाँ पर X and Y still turn out to be independent. So now I'm going to talk about the sum of independent random variables. independent and discrete random variables. Important that they are independent. Yes.
सर
जी
ये लास्ट स्टेप में p कहाँ से आया?
कौन सा वाला जी?
पॉइसन वाले पॉइसन में तो p नाम की कोई चीज नहीं होती.
पोसॉन में पी नाम की कोई चीज नो. पोसॉन के अंदर ये जो लैम्डा है, this lambda is the parameter of the Poisson distribution. So lambda times p is also a number. So this is a Poisson. This is a Poisson with parameter lambda p, and this is a Poisson with parameter 1 minus lambda, 1 minus p into lambda. ये एक पोसॉन है जिसका पैरामीटर जो है वो 1 minus p लैम्डा. ये एक पोसॉन है जिसका पैरामीटर लैम्डा p. ठीक है. So think of this कि ये लैम्डा जो है, लैम्डा और p जो है ये नंबर्स हैं. मैं अगर कहूं कि एक पोसॉन with पैरामीटर 5 है या एक पोसॉन with पैरामीटर 3 है, तो 5 को अगर मैं 0.6 से मल्टीप्लाई कर दूंगा तो 3 आ ही जाएगा. ओके. So sum of independent random variables. So let's say we have x and y as discrete random variables, and we are interested in the distribution of their sum. We are interested in probability x plus y is equal to a. X and y are independent discrete random variables. So I can write it by using the law of total probability. By using the law of total probability, this is equal to summation over yi probability x plus y is equal to a and y taking a value y taking a value yi, summed over all y's, summed over all y's. So this is simply law of total probability. ये partitions ही की हैं और कुछ भी नहीं. So this will turn out to be equal to the probability y when y takes the value yi. So that means I can write that x takes the value a minus yi and y taking a value yi. Convince yourself that this event and this event, these two are exactly the same. When x and y are independent, I can actually write it to be equal to summation of yi probability x taking a value a minus yi, and then probability ये independent अगर होंगे तो मैं इसको separate out कर सकता हूँ. Probability y taking a value y. I can separate these out only if x and y are independent. और ये हमने दिया हुआ है independent random variables. So I will continue with that example that we did earlier, two Poissons. So this example is very much related to the example of Poissons, males and females entering the post office that we did earlier. So I'm going to talk about sum of two independent Poissons. वहां पे हमने ये देखा था कि you had a Poisson with lambda, Poisson with parameter lambda. ठीक है, जिसमें से p is the probability that the person entering the post office is male, 1 minus p is the probability that it's a female. So हमने ये देखा कि this probability, joint probability, will turn out to be equal to this Poisson lambda p and Poisson 1 minus p lambda. So males को अपने अलग कर दिया और females को अलग कर दिया. Males का जो average rate है is lambda times p. Lambda is the average rate of the total number of people entering the post office. P% of those are fraction p of those are males, fraction 1 minus p of those are females. तो females और males का जो rate है उनको add करके आपके पास lambda होना चाहिए, which is the total rate. Now let's talk about the sum of two independent Poissons. Okay. So let's say you have x, which is Poisson lambda, and y, which is also a Poisson with parameter mu. And let's say that these two are independent of each other. So first question is, what is the PMF of x plus y. Pmf of x plus y. So using this expression here, Pmf of x plus y, Pmf of x plus y x plus y taking value a, which is equal to summation upon y going from 0 to infinity. Poisson values can go from 0 to infinity. Probability y taking a value small y, okay, and x taking a value a minus y. ये बिल्कुल मैंने exactly ये वाली expression जो है इसी को नीचे लिख दिया. It's the same expression that I have written here. Yeah, this expression. And the reason I can separate out y and x is because x and y are independent given. Otherwise, मैं यहाँ पे stuck हो जाता. So this expression is true. ये वाली जो box में डाली हुई है, this expression is true in general. But नीचे वाली expression is true when they are independent. तो मैंने x और y की terms को separate कर दिया. So x and y होना चाहिए. Right. So x and y are given to you. उनके parameters भी आपको बता दिए गए हैं. Now we are asking what is the probability y is equal to y. Y is a Poisson. Y is a Poisson. So let me just first fix the sum here. Okay, y going from 0 to a. Why did I fix it to a? इसको हमने a तक इसलिए fix किया क्योंकि Poisson random variable cannot be negative. Number of typos on a page, number of packets arriving on a network, in a computer network, it cannot be negative. Typos कभी negative नहीं हो सकते. Number of people standing in a queue at PDC line, negative नहीं हो सकते. So Poisson random variable, Poisson random variable will take positive values on. If that is the case, that means that x can never be negative, which means that y cannot be smaller than a, y cannot be greater than a. So that means y must go from 0 to a into probability of y taking value y, probability of x taking value a minus y. So y taking a value y, what is this probability? What is this probability? Y going from 0 to a, y taking a value y is a Poisson mu. Y is a Poisson mu. So this should be equal to mu power small y e to the minus mu divided by y factorial. ये मैंने Poisson की probability लिख दिया. ये Poisson का PMF. Similarly, x is also a Poisson. उसका PMF भी हमने a minus y के ऊपर लिखना है. So this would be equal to lambda. X is a Poisson with parameter lambda. Lambda power a minus y e to the minus lambda over a minus y factorial. A minus y factorial. Right. So I'm going to rearrange this a little bit. So you can notice here that you have a y factorial here, a minus y factorial here. मैं ऐसा करता हूँ कि यहाँ पे a factorial से multiply a factorial से divide कर देता हूँ. ठीक है? So these terms here together, this y factorial and this a factorial and this guy here, ये वाली जो तीन terms हैं, ये आपको दे देंगी a choose y. This is a choose y. ये मैंने a factorial से multiply divide किया ताकि मैं इसको a choose y की शक्ल में लिख सकता हूँ. And this would be 1 over a factorial, एक वो साथ आ जाएगा. And then you also have e to the minus, ये e to the minus lambda and e to the minus mu. So e to the minus lambda plus mu, ये आ गया आपके पास. E to the minus lambda plus mu. Okay, and then you have mu power y and lambda power a minus y. Okay. Now I'm going to write this as summation y is equal to 0 to a e to the minus lambda plus mu divided by a factorial. एक ही आ गया आपके पास. And then a choose y, mu power y, lambda power a minus 1. So this guy here जो पहले शुरू में ये लिखा है, this guy is, there is no y in here, there is no y in here, इसको मैं summation से बाहर पुल कर लेता हूँ. So e to the minus lambda plus mu divided by a factorial. बाकी चीज क्या बच जाती है? Summation y is equal to 0 to a of this guy. What is this guy? इसको recognize करो. What is this guy? किसी को याद है a plus b power n की जो expansion होती है? So that's the binomial expansion. It's a binomial expansion. So it's exactly the same. It's exactly the same. And this guy here is simply lambda plus mu power a. Lambda plus mu power a. And what is this guy? What is this guy? This guy is a Poisson with parameters lambda plus mu. Lambda plus mu. So now I compare these two questions. कि वो एक हमारे पास पोस्ट ऑफिस वाला था, एक पोस्ट ऑफिस वाला था जिसके अंदर लैम्डा का अराइवल रेट था for both males and females together. For both males and females together. P was the probability कि वो मेल होगा, 1 minus P was the probability कि वो फीमेल. ठीक है? So मेल का जो रेट है यहाँ पे लैम्डा टाइम्स P होगा, फीमेल्स का रेट लैम्डा टाइम्स 1 minus P होगा. यहाँ पर हमने देखा था कि this Poisson lambda P and Poisson 1 minus P lambda. तो इनका जो जॉइंट है आपके पास, this would be Poisson lambda. So this is the same thing as saying कि ये आपके पास x और y हैं जो Poisson mu और lambda वाले आ रही हैं आपके पास, and the sum of these two guys is a Poisson, is also a Poisson random variable with rate mu plus lambda. So these two questions are sort of complementary to each other. B part. So I am also interested in finding the probability that x takes the value x given that x plus y is equal to some fixed number w. So this is the conditional of x given that x plus y is equal to w. So again, ये आपको x और y दिए, which are independent Poisson random variables. If x plus y is given to you, what is the probability that x takes the value x? Now, once again, realize कि ये बिल्कुल आपके पास कोई केस बन जाता है कि now you have W trials और उस W trials में से आपको small x successes चाहिए. W trials में से small x successes चाहिए. And what is the probability of success in each trial? वो हम figure out कर सकते हैं. उसके लिए हम solve करेंगे and we will see that this guy turns out to be a binomial. हमें इसके parameters नहीं पता. Well, एक तो parameter हमें वैसे इसका idea है कि this would be W, total number of trials. What is the probability of success in each trial? Well, we can make a guess. लेकिन guess करने के बजाय we will let the math speak. So solve करें इसको in the notes. ये notes में solve किया हुआ है. Please take a look at that. So more on independence of random variables. So I'm stating this without proof, but the proof is extremely simple. Okay, if x and y are independent, then expected value of some function of x and some function of y, g of x and h of y, this would be equal to the product of these gx, expected value of h of y. तो ये कहां से आता है? ये वहीं से आएगा आपके पास कि if x and y are independent, then their PMFs, they get separated out. The product of x and y is PMF would give you the joint PMF of x and y. So expected value of gx multiplied by h of y, this would be equal to the separate expectations. And a special case for that is expected value of g of x is x. ये एक ऐसा function है जो unity function x and y is equal to expected value of x, expected value of y. Only when they are independent. Only when they are independent. If x and y are independent, only when they are independent, then we can write this. Another thing that we can write about x and y is the variance of x plus y. Variance of x plus y. If they are independent, this would be equal to variance of x plus variance of y. ये हम prove नहीं कर रहे, but I will leave this proof as an exercise. In notes में भी नहीं किया. You can take a look at it from some book. So finally, I'm going to cover another interesting topic, which is called conditional expectations. Conditional expectations. Conditional expectations. So notice that x given y is equal to y. X given y is equal to y is a random variable. अगर आपको मैं बता दूंगा y takes a value y, it's an event which happens. And then I ask you, okay, what is the probability mass function of x given y is equal to y? X given y is equal to y is a random variable. Is a random variable. I can find this expected value is a random variable. ये ऐसा random variable है जिसका PMF, whose PMF depends on small y. Depends on small y. So I can find expected value of x given y is equal to y. Now, since x given y is equal to y is a random variable, उसकी expected value find करेंगे अगर, तो is a constant. Is a constant. Is a constant, but it is not a constant which is independent. It's a constant whose value depends on y. Whose value depends on y. Okay. So that means that this guy here is a function of small y, function of small y. What that means is the expected value of x given y is a function of capital Y. And a function of a random variable, capital Y is a random variable, and a function of a random variable is also a random variable. Function of a random variable is also a random variable, which means expected value of x given y is a random variable. If it is a random variable, it will have a mean, it will have a variance. Okay? So I can talk about the expected value of x given y. So ये अंदर वाला जो है ये एक random variable है. It's a random variable, and this expectation is with respect to x. And the outside expectation is with respect to y, with respect to y. Okay. And the claim is that this turns out to be equal to expected value of x. ये एक आपके पास constant आ जाता है. बिल्कुल उसी तरह से कि expected value of x given y, expected value of x given y, this guy is a random variable. इस random variable की expected value अगर निकालें, इस random variable की expected value निकालें, I will get a constant. क्योंकि किसी random variable की expected value निकालें, constant मिलती है. And that constant value turns out to be equal to the expected value of x. There is a little proof for that, and very easy proof given in the notes. Just 2-line proof. Please take a look at that. ये सिर्फ summation को आगे पीछे करना है. And we have an example for that. We have an example. And the example is, let's say you are sending emails to various people. Sending emails to various people. So lumps से भेजने. So within lumps, if you are sending email within lumps, there is a probability associated with that. Probability associated with that is 50% of the time you send email within lumps. Outside lumps, but in PK, in Pakistan, the probability of that is 0.3, and outside PK, the probability of that is And then let's say you have average sending time, email sending time जो है आपके पास लम्स के अंदर अगर आप भेज रहे हैं 0.05 seconds, लम्स से बाहर भेज रहे हैं बट विद इन पाकिस्तान इज 0.10 seconds, डबल हो जाता है, और उससे भी बाहर भेज रहे हैं तो मजीद ट्रिपल हो जाता है. So let x is equal to the sending time. It's a random variable. It's the sending time. And y is your destination, which could be lumps within pk and foreign. So let me define y to be equal to 1 if it is local, y to be 2 when it is within Pakistan, y to be 3 when it is a foreign email. So I am interested in expected value of x, in expected value of x. You can find the expected value of x by conditioning on y, expected value of x given y, expected value of x given y. So now this would be equal to, so this expectation is with respect to y, this expectation is with respect to x, So this would be equal to summation upon all y, expected value of x given y. Oops. Taking a value small y into py of y. बिल्कुल उसी तरह से जैसे आप नॉर्मली एक्सपेक्टेशंस फाइंड करते हैं कि एक्सपेक्टेशन नॉर्मली कैसे फाइंड करते हैं, प्रोबेबिलिटी मल्टीप्लाइड बाय द कोरस्पॉन्डिंग वैल्यू, एंड द कोरस्पॉन्डिंग वैल्यू इज expected value of x given y is equal to 1. Now what are these values? ये y की probabilities तो हमें पता है कि ये आपके पास है 0.5, 0.3, 0.2, y takes a value 1, 2 and 3 with probabilities 0.5, 0.3, 0.2. So ये हमें पता है. I am interested in finding this. What is the value of expected value of x given y is equal to 1? What is the expected value of x given y is equal to 1? ये भी आपको दिया हुआ है कि ये 0.5 seconds is 0.05. Expected value of x given y is equal to 2 is equal to 0.1, and expected value of x given y is equal to 3 is equal to 0.3. ये सब आपके पास आ गई. So you can find this to be equal to 0.05 into 0.5 plus 0.10 into 0.3 plus 0.3 into 0.2. ये भी जो भी आपके पास आंसर है, जो भी आंसर आपके. So there is a couple of more examples, two more examples in the notes. Please take a look at those examples as well. Aun, you have a question? So anyone has a question? Okay. So I think we are, it's about time to close the session. If there are any questions, I will be happy to answer, unless we will stop the sharing and close the session. कोई question है किसी का?
Sir, the last bit is only for independent random variables, right? Expectation of x is equals to expectation of, and then expectation of x given by.
This does not require independence of x.
Oh, okay. Okay, understood. Thank you.
Okay. Any other question? Okay, great. Thank you very much. we will have some more practice problems for the homework. I will upload the homework today. Thank you very much.